Magnetic pulse welding is a solid-state welding process that uses magnetic forces to weld two workpieces together. The welding mechanism is most similar to that of explosion welding. Magnetic pulse welding started in the early 1970s, when the automotive industry began to use solid-state welding. The biggest advantage using magnetic pulse welding is that the formation of brittle intermetallic phases is avoided. Therefore, dissimilar metals can be welded, which cannot be joined by fusion welding. With magnetic pulse welding, high-quality welds in similar and dissimilar metals can be made in microseconds without the need for shielding gases or welding consumables. Process. Magnetic pulse welding is based on a very short electromagnetic pulse, which is obtained by a fast discharge of capacitors through low-inductance switches into a coil. The pulse current with a very high amplitude and frequency produces a high-density magnetic field, which creates an eddy current in one of the workpieces. Repulsive Lorentz forces are created and a high magnetic pressure well beyond the material yields strength, causing acceleration, and one of the workpieces impacts onto the other part with a collision velocity up to 500 meters per second. During magnetic pulse welding, a high plastic deformation is developed along with high shear strain and oxide disruption thanks to the jet and high temperatures near the collision zone. This leads to solid-state weld due to the microstructure refinement, dislocation cells, slip bends, micro-twins, and local recrystallization principles. In order to get a strong weld, several conditions have to be reached. Jetting condition. The collision has to be subsonic compared to the local material speed of sound to generate a jet. High pressure regime. The impact velocity has to be sufficient to obtain a hydrodynamic regime, otherwise the parts will only be crimped or formed. No fusion during the collision. If the pressure is too high, the materials can locally melt and re-solidify. This can cause a weak weld. The main difference between magnetic pulse welding and explosive welding is that the collision angle and the velocity are almost constant during the explosive welding process, while in magnetic pulse welding they continuously vary. Advantages of MPW: allows welding of designs which with other processes are challenging and not possible. High-speed pulse lasts from 10 to 100 microseconds. The only time limitation is loading and unloading and capacitor charge time. High repeatability, suited to mass production, typically 1 to 5 million welds per year. Dissimilar metals welding is possible. Weld with no heat-affected zone. No need for filler materials. Green process. No smoke, no radiation, and no extraction equipment required. High-quality clean interface. Mechanical strength of the joint is stronger than that of the parent material. High precision obtainable by adjustment of magnetic field. No distortion. Almost zero residual stresses. No corrosion development in the welding area.